This video is for class 9 physics, and in this video we are dealing with the topic principle of flotation. We have already read that when a body is immersed in liquid, the following two forces acts on the body. I hope you can guess those forces. They are weight of the body, which acts vertically downwards and tries to sink the body, and it is acting through the center of gravity, right? And the second force is the upthrust, right, of the liquid acting vertically upwards through the center of buoyancy, that is the center of gravity of the displaced liquid. The upthrust or the buoyant force is equal in magnitude to the weight of the liquid displaced. This force has tendency to make the body float. Okay, these all things whatever I have read just now, we have already completed when we started the chapter. Now as you all know, the center of buoyancy is the center of gravity of the displaced liquid, right? We have already discussed this point also. The upthrust of the buoyant force is equal in magnitude to the weight of the liquid displaced. In fact, we had a mathematical proof for this also, that is V rho g. Okay, this force has a tendency to make the body float. Obviously the upthrust is acting upwards, so it has the tendency to make the body float. Now figure 5.9 shows two forces, weight, that is W, and the upthrust, that is Fb, acting on the body floating on a liquid. So here we can see the diagram. It shows the weight of the object which acts vertically downwards through the center of gravity, and the upthrust which acts vertically upwards through the center of buoyancy, right, when the object is floating or immersed in a liquid. Now under this scenario we have three conditions, three cases, right? Before going through those three cases, let us see what will be the value of this weight. The value of this weight will be equal to V rho g, which is the volume of the total body, that is capital V. Okay, the whole body is volume, right, and multiplied by the rho s, that is the density of the solid, rho s, and the acceleration due to gravity, right, and the acceleration due to gravity. Whereas the upthrust, here this one upthrust, the upthrust will be equal to small v, that is the submerged part of the body, this part of the body, multiplied by the density of the liquid, and then multiplied by acceleration due to gravity. Okay, so these are the three factors on which this upthrust depends, right? So in magnitude, W equals to volume of the body multiplied by the density of the body multiplied by acceleration due to gravity, and the upthrust is equal to the volume of the submerged part of the body multiplied by the density of the liquid and then multiplied by acceleration due to gravity. We have done this portion also before, right, when we were discussing the part B of this chapter number 5. Now obviously the upthrust Fb is maximum, that is Fb dash, when the body is completely immersed inside the liquid. So depending upon whether the maximum upthrust, that is Fb dash, depending upon whether the maximum upthrust, that is Fb dash, is less than, equal to, or greater than the weight, the body will either sink or float in the liquid. So we consider the following three cases. Case 1, when the weight of the object is more than the total upthrust. Number 2, when the weight of the object is equal to the upthrust and the weight of the object is less than the upthrust. So in case 1, when weight of the object is more than the total upthrust, that is the weight of the object is greater than the weight of the displaced liquid, in this case the body will sink as shown in the figure 5.10. The apparent weight of the body, that is the weight of the body inside the liquid, we have done sums on this also, remember, as measured by the spring balance it is attached with the body, will be W minus Fb dash, that is W is the total weight of the object, right, minus the upthrust acting vertically downwards. This is the case when the density rho of solid is greater than the density rho L of the liquid, right. We have proved this also, if you remember. Okay, let us check out the second case. The second case, when the weight of the object is equal to the total of thrust, that is the weight of the body is equal to the weight of the displaced liquid. So in this case the body will float just below the surface of the liquid as shown in the figure. The apparent weight of the body will be 0. Remember, the apparent weight will be 0 whenever the body is floating. So the density rho of such a body is equal to the density rho L of the liquid. We have proved this also before, right? And in case 3, when the weight of the body is less than the total of thrust, that is the weight of the body is less than the weight of the liquid displaced by it when it is held completely immersed in the liquid. So in this case the body will float right, partially above and partially below the surface of the liquid as shown in the figure 5.12. Only that much portion of the body gets submerged by which the weight of the body by which the weight of the displaced liquid becomes equal to the weight of the body. So in this situation what happens, we do not have total upthrust, we have only upthrust. Why? Because the total body is not immersed, so we have only FB. Remember this, right? So in this situation, while floating, the weight acts at the center of gravity G of the body, while the upthrust FB acts at the center of buoyancy B, which is vertically below G, and the weight is equal to the upthrust, that is FB only, due to the submerged part of the body. Thus the apparent weight of the body will be 0 because it is floating. So the density rho of such a body is less than the density rho L of the liquid. We have proved this part also before. Now from the above discussion we find that for a floating body, this is the main part here from the above discussions, this is the principle of flotation here, right? Weight of the body is equal to the weight of the liquid displaced by the submerged part of the body, that is upthrust, during flotation. Okay, this is only true for floating body. So here they are saying us the weight of the object should be equal to the upthrust, and right, the apparent weight of the floating body should be always 0, right? So this is the principle of flotation. Thus according to the principle of flotation, the weight of the body is equal to the weight of the liquid displaced by its submerged part, and the apparent weight is 0, right? I hope you have understood the topic. Okay, this much for this video. Thank you so much.